There's a lot to talk about. But I'm going to introduce my friend Marshall Smith, who is at NASA headquarters responsible for mission planning for a lot of different things, and has always been the model for the 3-day beard. And I think that's always been great for you, Marshall. So I'm going to leave it to you, and you can introduce the rest of your panel.
Okay, great. Thank you. All right. Well, what I think I'll do is I'll first go through the panel here and just introduce real quick who we have here. As Chris said, I am actually the Director of Human Lunar Exploration Program, so what we're doing, a lot of what we're doing for Moon to Mars and moving on is in this area that I'm working. So I will moderate this panel, and when we get to the end, I'm sure we won't have any questions about what's going on. So anyway, to my left here, immediately left, is Dan Hartman. He is from Johnson Space Flight Center. He is the Gateway Program Manager, and Dan is managing, obviously as the Program Manager, managing the development of Gateway and overseeing the power propulsion element, the PPE, the HALO, which is the Habitation and Logistics Outpost, which is a small habitation volume that we're going to use to dock to when the lander gets up there, as well as Orion and the logistics element. And of course, the Gateway Logistics element services as well. So he's handling that. To his left is Lisa Watson-Morgan, and she is from Marshall Space Flight Center, and she is the Human Landing System Program Manager. She's been on board, 2-3 months now? It's been a wild ride so far. And she's been running at full speed, collaborating with U.S. industry and working within the government to get a human landing system out and on contract. That's our number one task right now, and we're working to develop, integrate, and conduct crew tests of this human landing system by 2024. And then to her left is Lindsay Aitchison. Lindsay is from NASA headquarters. She is the EVA strategy lead for advanced exploration systems. Lindsay is the spacesuit, she's my spacesuit expert. So anything comes up with spacesuits, I ask Lindsay. So Lindsay is the spacesuit and EVA expert at HQ, and she is coordinating the development, acquisition, and evolution strategy for the XEMU spacesuit, which she'll talk about when she has a few minutes. And then finally, at the end, last but not least, is Michelle Rucker. She is from Johnson Space Flight Center. She is leading the Mars Integration Group. And what she's doing is looking at how we're going to go to Mars holistically. You know, what is our Mars architecture strategy, working our studies, analyzing key trades, and how we leverage and anticipate to make investments into the human missions to Mars, really focusing in on a 2030s type of time frame is where we're going. So with that, I think that's all the folks that we have today, and I will go ahead. Let's go to the next, please. We have a few slides, and each of us only have a couple slides. Next. One more. Okay, great. So what I wanted to do is just show a slide, just a general overview of what the plan that we're working to. For Artemis Phase 1, Artemis is the twin sister of Apollo, the goddess of the moon, and that is the name of the systems that we're taking to get to the moon in 2024 and on the lunar surface. So Artemis 1 is formerly known as EM1. Those of you who've been coming to these meetings we've talked about EM1. There's no change there. It is the first human spacecraft to go to the moon in the 21st century. And we will be conducting a distant retrograde orbit type mission, and then coming back from that complicated mission where we're uncrewed, and then recovering the vehicle. That'll be the first test flight, and then crewed test flight. For Artemis 2, we will be sending the first humans into orbit. First, we'll do a highly elliptical orbit. It's actually the same mission as EM2. Do a highly elliptical orbit where we'll check out the ECLSS systems and other crewed systems, and then once we're confident after that 24-hour period, we'll select to go to the moon, do a lunar flyby, and return. At that point, the vehicle will be ready to be used for crewed missions out at the cislunar area. The first Artemis support mission will go up. It'll be a solar electric propulsion system called the PPE that Dan's program will launch. That's in December of 2022. It has a 1-year demo period where we'll be taking data on the solar electric propulsion system because that's a key technology to enable us to go to Mars. And then following that, the second Artemis support mission will go up. It'll be the first pressurized module to be delivered. That's called the HALO, which again is under the Gateway. It's part of the Gateway. Followed by a logistics element that will be launched that will carry surface logistics that we'll need to go to the surface of the moon. And the next major component will be from Lisa's program, the human landing system, which will be delivered to the gateway. It'll be multiple launches we expect, but we're in the process of getting proposals on those, and we'll see how those come out. And then finally, we'll launch an SLS with an Orion to the gateway, which will already be docked with the and we'll dock to the gateway where we'll have the HLS and the logistics waiting for the crew. They'll board the system. They'll get any logistics out they need to go down. Two of the crew will go down to the surface of the moon, conduct EVAs, collect science, those types of things, and come back. And then they'll return home in the Orion. So that's the first mission. In the meantime, science and STMD will be playing a huge role in helping us enable these missions. First of all, we have Commercial Lunar Payload Services, or CLPS we call it. They'll be launching 2 to 3 missions per year starting in 2020. These will be small payloads that will be taking scientific instruments and other capabilities and to learn information about the South Pole and other parts of the moon. We'll be doing those throughout this period. Also, science is looking, and CLPS is looking at a large-scale cargo lander, which could deliver something like a rover or a large experiment that we would want to have much higher mass potential than say on the normal CLPS type of systems. So those also will be done. That's looking at a 23 timeframe leading up to the 24 mission with humans on the moon. So that's the whole Artemis Phase 1 approach. Next. So with that, I just wanted to show you an image overall of the vehicle. Now this is the PPE you see in the back there with the solar array wings producing power for the halo for the system. The halo is the center component. I'll let Dan talk about those two components. The logistics element is on the left that comes up to supply the system, and then that's the concept that we have for the design reference for the landing system right now with an ascent element, then a descent element, and a transfer vehicle to get to low lunar orbit. So with that, I'm going to go ahead and turn it over to Dan, and Dan's going to say a few words.
Okay. Mics are hot, or I don't get a green light. Good to go. You know, Mary Lynn mentioned earlier, it's nice to see hardware and be around hardware, and I can tell you the PPE and both the Halo have production moving, okay? So this is real. We got contracts in place and real hardware is being built. As Marshall mentioned, we selected Maxar for the PPE element in May, and really what that does is makes use of a commercial bus that they have a lot of familiarity with a 1300 bus, and so it is going to be based off of that. Marshall, we mentioned is launch in late 2022, and so we're still on track for that, we believe. There are some integration things when you try to marry a commercial bus into an integrated spacecraft. There will be some changes, and we're starting to work through those with the Glenn Research Center, who's managing this activity, and Maxar. It will do a 1-year checkout. We may play into that time a little bit if we need some schedule margin to keep it on the ground. I think there's plenty of time to do the checkout of the advanced solar electric propulsion systems, get the arrays out, get the system in decent shape, and get it into the NRHO orbit. And so we're looking forward to that. These arrays provide 60 kW of power, which is pretty significant. That's about 50% of what we have on the ISS. And this is a much smaller spacecraft. And so we think we're going to be fine from a power generation aspect. Obviously, when you do the solar electric propulsion burns, that does take power away. But in general, we think there's going to be plenty of power to distribute across the different components of the gateway and also fly payloads and take care of payloads. Our intent right now is to launch 2 payloads attached to the outside of the PPE when it goes up. And I think we just had a selection meeting, or our selection criteria and the candidate payloads that will be taken up early on. And so we're trying to make headway in the utilization of Gateway as well. One other unique thing about this is we are setting it up for it to be refuelable, both from the aft end of the power and propulsion element as well as the front end. Through the Halo structure going into the forward end of the PPE. The Europeans are very interested in launching a refueler, and so we think we can maintain PPE with the hydrazine and the xenon to keep it up and active for a very long time. And I guess I should have said next chart. It's just another picture of the PPE more specifically. Again, based off of the 1300 bus. You can see the antenna systems. It comes with primary redundant command and control antennas, X-band, Ka-band, and some S-band. We'll probably add another S-band onto the PPE here shortly. Next chart should be Halo. It's kind of the outline there. You can see it over there as well. Northrop Grumman is off building developing that module for us. It is highly leveraged off of the Cygnus spacecraft that we use to do the cargo resupply missions to the ISS. We will add an extra bay to it. I think the Cygnus today is a 3-bay. We'll add one more bay to get more room in there for the astronauts. And we need to, you can see the axial or the radial docking ports. And also you see that lander is actually pretty big. Of course, the real concepts will be coming. And so we think we need to get as much clearance away from the solar arrays and move those docking ports forward. And so by doing that, we needed to add an extra bay to the configuration. And so we have that in work presently with Northrop Grumman. As I mentioned, outfitted with 2 radial and 2 axial docking ports. It is really the hub of the gateway. All power distribution, all the avionics, all the software, command and control. I guess, you know, what do they call it? The command post. Gateway's a command post on orbit or around the moon. It is really associated with that Halo module. It will be the brains of the outfit as we're mechanizing it right now. Launch in late 23. We're still working with Northrop Grumman on that, on a commercial rocket. And what happens, you have the PPE up there already positioned. The Halo module comes in and does an automated rendezvous, proximity operations and docking directly into the PPE. That transfers the power, that gets the data systems up and going. In fact, every vehicle coming into the gateway will do this automated rendezvous and docking system. I'll mention a little bit later about the potential to retrieve payloads off the end of with the Canadarm3, but that won't come up for a few more years after we do this. We also plan to launch a metric ton of cargo inside. So that extra bay gives us room inside this vehicle. We have the up mass to take cargo and part of that cargo will be pressurized payloads inside. We also plan to make sure we supply the 2024 Boots on the Moon mission. If it's food and water, if we can offload some supplies from even inside a lander system or even off the Orion vehicle, anything we can get up there that helps the overall up mass to be successful for that 2024 mission, we're going to try to take advantage of. And potentially even if the EVA suits are ready to go early, we could get, I think we'll have the volume, it'll be close on the mass, but we think we can get the suits up in that time period as well. And then, like I said, we'll have payloads inside and on the outside that will operate off of the Halo module, and they will fly up, integrated and installed. So the next chart is our logistics, and this is really for all things, I'll say moon related, for gateway, for lander, just taking care of the needs of the mission. And that's the needs of the crew, that's the needs of the research on the surface of the moon. We're going to, like I said earlier, we'll probably put the suits in this logistics module. We'll hold it on the ground as long as we can, right up until the Orion mission, so we can add late cargo into that vehicle as needed. We think that's a good game plan to go down, and so that's the path we're on. 3.4 metric ton of pressurized cargo, metric ton of external cargo. First mission in 2024. And like I said, this is out for solicitation right now, so I don't think I'll get into any more details, but we're looking forward to have this capability up and running as well. And eventually, it'll be very CRS-based like we do on the ISS. And at the end of a logistics service mission, it'll be our trash disposal capability. So we'll fill it full of trash, remove the vehicle, and we'll bring up another one. So that's it for the first 3 elements that we plan to bring up.
Okay. Thanks, Lisa.
All right. Thanks a lot, Dan. So I'm really excited to be here today, really excited to be part of this panel. And I'm not sure if you noticed, but right before our panel started, we did have the Artemis human landing system stand-up come in. So just like everything with this program, we are just in time. I mean, we run right to the end, and we get it there right before we need to. And I will say that, you know, for folks who have been monitoring our broad agency announcement, we are working feverishly to try to get updates, to listen to industry, to make sure that we are working collectively and as collaboratively as we can in this endeavor. So as you know, HLS is charged with something very special. We are charged with putting 2 U.S. astronauts on the South Pole of the moon, which is a really big deal, especially coming off the heels of Apollo 11 and all of the fanfare from the summer. It has just been really overwhelming and exciting, you know, to start up this program. I would say another unique aspect is that we're going to land the first woman and the next man. And that has also generated a tremendous amount of excitement and media interest into what we're doing. And I don't know if I mentioned earlier, I think somebody did, maybe Marshall did, yeah. We have to do this by 2024. And, you know, that's easy, right? We'll be just in time, just like getting all the props that we need here. I mean, all kidding aside, this is a really, it's a critical procurement for the agency. We are going to be doing this differently, though, and I think having the space policy driver discussion right before this panel was, you know, very serendipitous, because wrapping our heads around our approach for this program, it's so different than anything we've worked on, certainly in my 30-year career. Typically, as I think most of you know, the government designs things. That's what we do. That's what NASA does. We come up with designs and government reference designs. We make sure designs close. We make sure the engineering is solid. We make sure we have margins. We do that preliminary work ahead of time, and it takes a long time to do that. Then after that, we hand over the design to the contractor community, at which time they typically implement, we iterate, things like that. Industry, for the most part, has been used to cost-plus type contracts. So human landing system and everything really that you're hearing here in this panel today is truly taking a different approach. We are listening to the administration. We are trying to be as forward-leaning as we can in making this more of a commercial endeavor. Our goals are to try to leverage the speed and the operating model of private industry, of best practices that they have, along with how NASA performs safety, understands crew, and has a rich heritage of design, development, test, and operations. So getting those two cultures together, I'm sure there'll be no problems at all, right? Yeah, okay, I'm glad you're still awake. So that's good. And so another interesting facet about how we're going to operate, we're not gonna, as you may know, DD-250. So we're not going to take ownership of the integrated lander systems. We're going to rely on, that's just another way of how how we have a higher reliance on commercial partnering. So the diagram, next chart. Sorry. My diagram, how about that? And so my only diagram, actually, because as I was mentioning earlier, we are in that iteration standpoint or phase, I guess, where we have requirements. We have 27 right now performance requirements that the HLS is designing to tell industry, here's what we want you to do. Now, as you know, NASA has a rich heritage of, as I mentioned earlier, knowing how to do things, having done them for years, and done them successfully. So the how portion, which I would call our design and construction standards, our safety, and our health and medical assets or facets of what we're doing. That is what we're using, I guess, in our new commercial approach here. We're working back and forth with industry after the first, in our first 3 months to try to negotiate down to the best set of those. And after that end of 3 months, then that's what we're going to be going forward with and executing. So what I have in front of you is a concept, and it's just an operational concept. It is not necessarily what is going to happen, because as you've heard me say, we're waiting to see what industry provides us. But of course, being good stewards, the government does have to do a government reference design and see if it's feasible and can close and all the stuff I mentioned earlier. And this is a representation of that. And since this is an end-to-end commercial solution, we do anticipate industry providing the commercial launch services as well. So a commercial launch vehicle, they will have to acquire that. They will have to integrate their spacecrafts, whether it's 1, 2, 3 stages, whatever their concept is. They will launch those up towards Gateway. They will aggregate, they will dock. If needed, then they will dock to the Gateway. And after they dock to the Gateway, then it's very important for us to make sure that it checks out. So we're launching this obviously without crew. That's what you've heard so far. So how does crew get there? Well, as you can see over here, you know, the SLS Orion, that is a big job, and that is something that we are leaving, you know, for the government industry team to do, getting the crew up to the Gateway. And once we check out, the crew gets there, that's when we get to do the magic that HLS is going to get to do. So we're going to take 2 crew down to the South Pole. We are going to take materials, you know, materials that are going to be needed. They're going to go down to the lunar surface, perform operations right now, 4 to 6 days, and we're still working towards what the right answer is there. We will perform EVAs, which, you know, Lindsay will talk to you a little bit more and about that. Then they will return to the Gateway, and that will be the end of our first mission. We do anticipate selecting more than one company, which I also think is very exciting. You know, taking a note from Commercial Crew and having a few actually in competition, I think is a good way for the government to get the best bang for the buck there. So our plan is to try to get as many, you know, as we can afford. And then we will have a down select to have 2, most likely, at which we'll run to see who gets there first. I know I'd want to be the first to get there. So we're excited to see what industry proposes. We are looking forward to creativity, not necessarily what, you know, the government design. The government design is great, don't get me wrong. But if we wanted our design, we would have just handed it over. And so we're really interested in hearing what solutions you have that are unique, that are different, and that will help us make the goal of getting to 2024. Because as you heard from the last panel, I think I wrote it down, bigger, higher, farther, faster, now. I thought that was very interesting. So thank you.
Thanks. Hey, Lindsay wants this.
Oh, yeah, I don't-
Okay, so Lindsay? You did
All
it.
right, right direction, excellent. So, for those who may not know, NASA has actually been investing in a very methodical manner how we're going to do exploration spacesuit development for about the past decade. So there's been a lot of work that we've done. We're taking the lessons learned from the ISS program, but also looking forward to the future of exploration. This is something that's somewhat nebulous. Your requirements evolve as your missions mature. And so really when we think about this, you look at our portable life support system. We started investing with industry very early on for some of those key components, new technologies that are required for both continuous CO2 removal, a really robust robust thermal loop system, as well as new regulators that can provide basically infinite number of set points within our band of operation. And so we really honed those specific component technologies, and then we're able to integrate them into a system and really focus on system performance. How do all these new technologies work together to inform a better system design? From there, we went to our first package system. And so again, it's a very methodical approach, trying to take something from the size of basically our office down to the first packaged portable life support system and getting even smaller so we can meet the needs of exploration. Similarly, when you look at the pressure garment subsystem, we're talking about really improving your capabilities, enhancing performance by looking at the mobility features you have in the suit, as well as how well it fits our entire crew population. So focusing on those design elements, we come through to a system that really optimizes the mass that it takes to get that added mobility, but also the size and packaging of the system as a whole into what we now call our exploration EMU. And that's what we're going forward with for our exploration programs. It's a very flexible architecture, meaning that while the first few iterations will be absolutely optimized for the lunar surface, we have very well-defined physical and functional interfaces between all parts of our system, so it can be easily modified to support any mission that we have going forward, whether it's at the gateway or all the way to the surface of Mars. We really wanted to have a system that would evolve. So diving in just a little bit more specifically on the portable life support system, you can see that idea in that we have a motherboard system design. So we have a backplate, that's our titanium backplate to, again, focus on mass savings. But we have all of our fluid lines embedded into that, and it's a single layer architecture. That way, if you need to access any component, you can do that very easily and very quickly. And you can also swap components out, whether it's because it's a failure or a better technology has come online, you can swap it in without having to redesign the entire system. Other things that we've done is we've actually moved some of the PLIS components into the pressurized volume of your suit. That helps you save a lot in terms of structure that you would have had otherwise inside your backpack. You move that inside and take up some of that dead space in the suit. It's optimizing the system for volume overall. Another big lesson learned is we now have a very small display and control unit on the front of the suit as opposed to the large, very mechanical driven one that you've had in the past. And that makes it both easier to reprogram the suit as needed on the fly, but also makes it much easier to fit a wider variety of crew members. On the pressure garment side, it may not look like we've done a lot of major evolutions if you look at the history of our prototypes, but this is the XEMU prototype. Things that are really particularly important on this is we now have a rear entry suit design. Rear entry is very important because it helps not only get greater mobility in your upper body, but it also reduces the risks of injuries to the shoulders that we've seen in some of our other programs. We're really focusing on increasing performance and increasing safety of the system. We've done over 30 MBL runs, so in the pool, testing out that design, learning what works, what doesn't, what's helping your performance, what's hurting. So we've made a lot of progress and really iterated on this design, so now we have a very mature system overall. The XEMU actually just completed its PDR design, and so we're moving into DVT testing in 2020. We'll be sending up our entire thermal loop for testing on the ISS, followed by a full suit demonstration in 23, and be ready for the Artemis demonstration in 2024.
So let's change coordinate systems now. So the entirety of human spaceflight has revolved around the Earth up till now. But to get to Mars, we have to think about revolving around the sun. So it's a little bit different. To get to Mars, first we have to chase Mars around the sun, and then Earth isn't where we left it, so then we have to chase Earth to get back home again. So it's a completely different type of mission than the missions either to low Earth orbit or to the moon. To be honest, Mars is difficult if you try to start from scratch, but we don't need to start from scratch. And that's an idea that goes all the way back to von Braun. So 2 weeks after we landed on the moon the first time, he was already proposing essentially supersizing the Apollo systems and going to Mars. He was ready to go to Mars in 1969. We're going a little bit further. Since 1969, we've got a lot of different tools in the toolbox now. So for example, we've got the heavy lift capability in development, so that's good. I can take advantage of that to help us get our cargo to Mars. We've got Orion almost ready to fly its first mission. So that's going to get the crew back and forth between Earth and Earth orbit. We've got the commercial capabilities in development, so we can get cargo resupply, refueling. So all those things we essentially get a kickstart on for an eventual Mars program. The Gateway program is going to offer us some solar electric propulsion. That's a technology that is in the trade space for going to Mars. So it's essentially, Dan calls it the gateway, I call it my prototype deep space transport. He's going to do some in-space assembly a little bit further away from low Earth orbit, so it's a little bit more difficult. He's going to be in a deep space environment with the radiation environment. It's a little bit more hostile, so we'll take advantage of that. When we get ready to build our Mars systems, Gateway offers a pretty nice stable orbit for us to stage our testing from. We've got the ISS. We'll do as much as we can on ISS. The advanced life support systems are already being tested on ISS. We're looking at crew analogs, where we bring crew home from ISS and put them through the first sorts of activities that they would do if they just landed on Mars, just to understand the health and human responses for a long duration space flight, and then landing and having to immediately get up and go do some serious tasks. The Space Communications Network is already in place. We probably need to look at where there's gaps to get us to Mars and back, and fill those gaps in where we can. And then, of course, we're going to have the spacesuits. The current spacesuit that we fly in ISS is for microgravity. It's not really designed for the dusty environments and for gravity. So Lindsay's going to get us halfway there with the lunar suit, and then we'll do a little bit of upgrade, and we'll be ready for Mars. And then, of course, the HLS system will give us crew landers. We're already eyeballing Lisa's ascent system. To ascend from the lunar surface to Gateway is not all that different than trying to ascend from the Mars surface up to a deep space transport that might be at 5 Sol Mars orbit. If we can use a common cabin, just change out the propulsion systems, we maybe get a head start on that. And then, of course, all the surface systems. Whatever we need on the surface, the habitation, the rovers, things like that, we'll take advantage of. I always like to say that lunar landers coming and going from the Gateway will look operationally very similar to Mars landers coming and going from the deep space transport. So we'll be able to practice all of our operations at the Gateway using HLS systems. When we get ready to build our prototype deep space transport, we can take it out to Gateway. We can have lunar landers even dock to it. To do end-to-end testing. We can't do that on Earth. There's really no better place to do that than at Gateway. And then, of course, a lot of the systems, some of the systems will be virtually identical. We'll just roll the dash number. Maybe it's a little bit more certification testing for a little bit different environment, but we're hoping as much as possible that the designers that are building these systems for the moon kind of have a Mars forward look in mind, and we can easily recertify those for Mars later.
Great, thank you. So we left ample time because we figured there might be a few questions. If not, I've got some prepared. So, and maybe we'll get the lights to stay on too. Worried about that. Let's see. So let's see. Do we have any questions out there? We'll get a mic to you. And
Okay, we have a problem in that most of the questions have come from the other side. So we need some of you guys up here to ask some questions.
oh, we
Got one way up in the back, making me work for it.
So I know that you showed your Artemis and Gateway and lander going down. What's the timeline for the rovers to be landing?
Yeah, so we've been looking at where we're going after phase 1. We would like to, obviously, if we're going to go to Mars in the 2030s timeframe, you know, we've got to talk about, you know, assets that we might want to put there. So we're probably talking late 20s timeframe is where we would be. That's an option that we're looking at. Those are all in study, and we're thinking about what that actual detail is. Right now, we're at the point where what we've rolled out in our current budget is that we're talking about some kind of surface asset, which may be a rover, it may be a HAB. We haven't decided yet.
So this is kind of an integrated Gateway lander question. With the highly elliptical Gateway orbit, you know, so the idea is to have a 3-stage lander, you know, to adjust the orbit, to be able to then have the propulsive descent with the with the descent stage and the ascent stage. Have you thought about adjusting that, the gateway orbit when the crews are on board to minimize the amount of elliptical orbit to kind of make that job a little bit easier?
Yeah, we actually have. We've actually done some analysis. We've done a lot of analysis. The gateway orbit, the halo orbit, wasn't something that just came up overnight. You know, we've been having people study gateway type systems. We call this one gateway, but you know, von Braun even had a concept of some kind of orbiting facility around the moon or spacecraft around the moon. And we've been looking at these for quite a while. There are always trades with how you go down this path. You've got trades of the FOMs that you want to have and how you want to divide your delta V. It takes X amount of delta V and that's it to go from one place to the other. And so when we looked at, say for example, a 24-hour orbit, something very, very easy and a little bit lower and would do exactly what you're talking about, the trades that you lost is we lost a lot of launch availability. So because of the orbital dynamics, the mechanics of the system, because we have a Block 1 SLS. So we ended up with that trade not being, the launch availability was basically unacceptable. It would not allow us to do the mission. So we actually backed off of that. And that's just an example of one of the orbits that we've looked at. We've looked at a lot of different orbits, though, and this seems to fit the right ballpark for the figures of merit that we have in our studies.
Any other questions up here?
Hi, I'm Tiffany from Marshall. I know the 2024 date for Boots on the Moon. What's the date, if there is one, for Boots on Mars?
So the 2030s have long been NASA's goal. Ultimately, it depends on what the policy and national priorities are. We just implement policy. We don't set policy. So just as with the Boots on the Moon by 2024, the Space Council made a recommendation. The Vice President set the policy, and off we're going. So we expect at some point something like that would happen for Mars. We'd get marching orders, and we will do what we can to meet those marching orders.
So question on International Space Station, getting all the parts working together, working all the interfaces was an extraordinary challenge. Y'all are approaching this sort of in a similar fashion, you know, with partnering with commercials and so forth. So I was just wondering, what thoughts are y'all giving into how you're going to get all these pieces from different vendors and so forth actually working together?
Great question. I think I sounded like, I can't see Dale, but it sounded like Dale's voice. Yes, and he was right in the middle of this on the ISS, as was I, quite honestly. And we ended up with a thing called MEIT at KSC, which allowed you to do multi-element flight-to-flight testing. If that lines up, which is not for certain, we'd love to do it. But in the interim, we know we're going to need docking checkout tools, right? So docking verification tools, both the active side and the passive side. We've done that on ISS. With the nodes already up there, and here comes SpaceX on demonstration mission number 1. It has a docking system, and it worked perfectly successful. So it can be done, but you got to lay out your verification plan. You got to have, like you said, Dale, you got to have great ICDs. You got to have good verification tools, and you got to make sure people communicate. So docking, that's basically your mechanical interfaces. We plan to have an avionics and software test facility centered around the Halo module that will go off and talk to PPE, go off and talk to the avionics and the HLS, Orion if we need to. Not quite sure there's going to be an avionics interface there and software interface exchange, certainly with the logistics module. So these things won't see each other like they lined up at KSC for the ISS. I remember being in the SSPF down there, and I think we had 8 or 9 different flight elements. And unfortunately, this was after the Columbia accident. But that did give us an opportunity to stitch a bunch of components and truss segments and modules together in an end-to-end fashion. You just basically, you didn't mate them, you ran umbilicals between them. If it allows, we'll try to go do that. Obviously, that means bringing, to a centralized location, so that has its logistics issues associated with that as well. But in the end, I would be very surprised if we don't do flight-like to flight-like testing before each one of these elements flew. It'll be probably at a component level versus integrated two pieces of hardware from a spacecraft seeing each other.
Yeah, and just to kind of add on to that, Dale, just from the human standpoint of that, our two program offices are starting, regular discussions in addition to our boards, starting to get together and tackle some of the same issues, so I know you were talking more of the hardware down the road, but to do that hardware down the road, you have to kind of set up what we're doing now and the relationships to make sure we're communicating as best as we can now in the early stages.
And I'll just add on to that a little bit. Both of you guys said this. We really are looking, one of the reasons we changed our approach, originally when we were on the 28 plan, we were going to buy all these components, get them individually. We were going to be the integrator, kind of very much more of a traditional approach. We changed our approach to the Appendix H approach, which is we're buying an integrated lander, integrated services, integrated launch. It's all done by one prime vendor, or really multiple contracts if we want multiple suppliers. But that solves a big part of that problem for the lander. Now, what Dan's pulling on is, we've got to dock these landers, different companies, to a Halo that was made by a company, to a PPE that was made by a different company. And so the approach he's pulling on, and the thing that he said that I really want to pull on is collaboration is key. Collaboration, just like in the government, we are collaborating very heavily. We are looking for vendors who want to collaborate with us and work very closely with us in the extreme. That's the only way this is going to happen by the time frame we have, is that we work together as a team to make these hard decisions and hard choices as we move forward, and do them quickly.
Yeah, hi, Dan Masnick, NASA Langley. I wonder if you could talk a little bit more about the international possibilities in terms of our international partners. We've got ESA providing the service module on Orion. We've got the Canada arm, but maybe some of the other possibilities that
Sure, I can run down them. So Canada, just like you mentioned, Canada Arm 3, we're making provisions to go launch. They'll probably be ready in the 25-26 time period. We're making provisions on one of our logistics contracts to allow that arm to be placed on the outside and launched. They're also providing grapple, we call them in space station PDGFs. They now call them LPGFs, I believe. And that's to allow the arm to basically do the slinky walk-around effect on the gateway as we need to for either science reasons, inspections reasons, or to do ORUs. So Canada, they'll also have some hardware that's going to fly on the PPE. We're going to fly a couple payloads up on a robotic device that Canada provides to allow, again, swap out of payloads. So they're early on, so Canada's early on. ESA is, obviously they're highly invested in the IHAB, and they're working that in concert with JAXA, the habitation module that we will see as part of the phase 2. They're also very interested in the refueler that I mentioned. I've seen some of the early numbers on, I'll say, momentum management on the vehicle. The need for refueling may actually be there, right? So I'm glad we have it at the forward end and at the aft end of the PPE. But these guys will have their ESA's proposing to build in a refueler that can go attached to one of the ports on the Halo module and then take care of at least a one-time refueling need for us. JAXA, like I mentioned, is participating in the IHAB with ESA, and they are also plan to develop the HTVX, which is a derivative off of what they fly today to the ISS. It basically changed from a berthing mechanism to a docking mechanism, upgrade some of their systems. The first 2 of those will fly to the ISS, and the remaining ones they're proposing to fly to HTVX, to the Gateway. And then the Russians, again, it's kind of timely because I was in Japan all last week, still feeling that jet lag. With all the program managers, that want to participate in Gateway. And so this is kind of the theme, the discussions of the hardware components that they want to provide. And then the Russians are still very interested in the airlock. And so, in my mind, to really have a sustainable lunar presence, the habitation module is going to be required, and an airlock to be able to do EVA to fix things is going to be required. We're also talking with the Russians about making that airlock also a science airlock. We have seen a lot of value out of the science airlock on the ISS and the GEM module. It's used more than we ever thought at the start, and so we think that will fold in, and we're trying to make that a common EVA science airlock design. All these international partners have work to do with their governments, just like we have work to do with our governments in 1.6 billion in 2020, right? So not everything's firmed up on their side. They're at different phases of where they're going through their ministerial conferences. Some are as early as November, some are in the February, March time period. And we're trying to wrap all these agreements around. We had in the ISS the intergovernmental agreements. And so we are going to be using the evolution clause that allows us to operate all of our participation, all of our legalese, it's basically a treaty style document that will be in place with the international partners. We're right now in the process of building the individual memorandums of agreement with these individual participants. And of course, this is where you get into the hard stuff of, well, this is what I'm going to provide, right? So I'm going to provide an IHAB, and what do I get in return? Of course, you know what they want to do as far as getting in return. They want to jump in, lease this module and go down to the surface, or at least go to the gateway. So those are a lot of discussions that are still out there in front of us. I will say much, much higher than our level probably at this table. But yeah, it's been, I mean, that's why they do it, right? That's why they participate in ISS. They like to get crew members up there, get the research done, somewhat show the flag. And I see that being very, very similar to how they play on Gateway in the lander program.
So I'll ask Lisa, how are we incorporating internationals on HLS? What's the approach?
So for the 2024 mission, we are not incorporating international partners.
Now, that we have our contracts in respect to that are, we have a domestic sourcing
Right.
clause in the contract, so 50% will have to be U.S. at least. It's up to the industry to go
It's up to
decide
them,
if
right.
they want to go get structures from somebody or some sensors or systems. That's up to them. It's all on them, and they have to, tanks, whatever, they have to do that. But it is not our desire, it is not our design to go do that initially. The other part of that equation, as far as internationals go, is, surface systems, HABs, rovers, scientific experiments we put on the gateway. All of those things are open. We're looking for contributions. We're looking for other countries to come to us and say, we really want to do this, and engage. And then, it's like Dan was talking about, what kind of in-kind trade would there be? Obviously, everybody wants to go to the surface of the lunar gateway, so those are discussions we're having.
Matt McSavany from Marshall. Considering that the HLS procurement model is new to NASA, are there analogs for this procurement model in other sectors of the government? And if so, what kind of V&V strategies have been successful?
What was the last part of the question? What kind of what strategies?
Verification.
Oh, verification, validation?
Yes.
Well, so I think, you can look at what we're doing on HLS, and we are doing a lot of, I guess you could look at commercial crew as somewhat of a pathfinder for us on this. Our organizational structure looks very similar. We, met with the NESC, the Engineering Safety group at NASA, as well as the tech authorities who work commercial crew, brought in some of their best practices of how, what materials did they need. And so that gets into a lot of how we're organizing the contract with our, data products. We're trying to have very few what's called DRDs. We're trying to minimize that. We're trying to make things to where the government has reach back or basically open into the different companies. So we can go pull the data and the information that we need to have insight that will then feed information into like the DVOs, the detailed verification objectives, that then will help us, lead us to certification and flight readiness. So a little bit from commercial crew, we're trying to lean in a little further. We're trying to, to have access. Those are some of the high-level things that we're initially trying to write into the contracts.
So the other thing I would add is that we're using the BAA, Broad Agency Announcement. It's not unusual in the government. Actually, DARPA and NRO have done those in the past. DARPA does a lot of them. I understand. Matter of fact, my lead acquisition person at headquarters, that was what they did at DARPA, and that's why we picked him up to start these BAAs that we have. It's called the Next Step Contract Vehicle, and this is why you hear Appendix H and Appendix E and Appendix A. The stuff that at the luncheon that Doug Comstock was talking about are 2 appendices that we have as well. So it's a little bit it's innovative for NASA. It allows us a little more flexibility and freedom to do things a little bit differently, which is why you see what's happening here with our ability to move quickly, still have a contract, still put requirements on a vendor, and yet be a little bit more open with how we do the interaction and get the contract through the system quickly.
Right, and a little less prescriptive on, in the past, NASA would say, give me a very detailed, down to the formatting and everything of a data package. And we're trying to minimize that because that does take extra time on the contractor side, but we still need access to the analysis, to the, to the drawings to understand, build to print and make sure that from a technical and engineering standpoint that we're good to go.
And we have time for one more right here in the middle.
Nick Morris from UAH. I guess I just wanted to ask how your plans change if Elon Musk beats you to Mars.
I missed that last part. How our plans change what?
If Elon beats us to Mars.
I expect SpaceX will probably submit a proposal. We'll see. I don't see this as a competition by any means. We're not competing with SpaceX or Blue Origin or Boeing or Lockheed. We have a contract and we're looking for folks to engage with us and help us accomplish our goals. It's not a us, them. It's not a new old. It's let's go to the moon and let's do it together. And I think that there's a lot of capability that SpaceX can bring to the table to make this happen.
Yeah, they were one of the companies, providing us feedback and as well as many other companies, and so we're listening to all of them, whether the ones that that Marshall listed, and I think it is important to know that NASA and all of private industry create the aerospace community. And it's a very symbiotic type relationship, and that's part of what I think you heard from the previous panel as well. Like I said, I think HLS is a direct result of let's try to find the best of what private industry has and the best of what the government has, and let's see if we can use that to enable speed, to try to get there together collectively as the United States of America.
Excellent.
Okay.
All right. Well, thank you very much, everybody. Thank you, panel.